Hello everyone, myself Soumyashri P, Assistant Professor, Department of Computer Science and Engineering. Okay, in the last session we have discussed about the Unix file concepts, which is under Module 2 of Unix system programming. We have discussed the concepts like directory files, the relationship between C stream pointers and then file descriptors, and different APIs in order to access files, okay, and also the inode numbers. So in today's class we shall discuss about the different hard links and symbolic links, as well as the Unix file APIs that are used in the Unix operating system. Okay. Okay. The first concept is hard links and symbolic links. Okay. Symbolic links are also called as soft links. A hard link in Unix operating system is nothing but a path name for a file. Okay, so it is nothing but a path name for a file. So in Unix operating system, so this path name, there will be only one hard link for a file by default. Anyways, user can increase the hard link count for a file by using ln command. So let me take the example, ln command. Okay. This command is used to increase or to create the hard link for a file. So hard link is nothing but a path name for a file. Okay. So ln, let me consider an example. Okay, this is the example. So ln command followed by the path, the file name to which the path name has to be created. Okay, so I have taken the old one. So this is the file name and this is the path name. So we can access the file either by referring this name or by referring this name. Okay, so both are same in this case. So hard links are nothing but the path name for a file. Okay, so that can be done by using ln command. So ln command, here we have the file name and next we have the path name using which we can refer to this file. Okay, so next let us see what are symbolic links, nothing but soft links. Actually symbolic links are also remains the same conceptually, and it we'll discuss about the differences later. Okay, so again symbolic link can be created by using same, that is ln command, but with an option -s. So it is created like this, ln -s. Okay. So again here it remains the same as a hard link, but we have to make use of -s option. Okay, so we have to make use of -s option. So that indicates we are creating symbolic links or soft links. Okay, so this is about hard link and symbolic links. Now let us see what is the purpose of creating hard link and symbolic link. Now let us see what is the purpose of creating hard link and symbolic link for a file. Okay, let me assume that we are in a directory called /user. Just for an example, I have considered this. Okay, so let us assume that we are in the directory of path like this. Okay, and each and every time we have to access a file, that is /user /include /sysbar unistd.h. Let us say that we are inside this directory and each and every time we have to access this file user, which is under this path, user include sysbar unistd.h. Okay, now let us create a hard link for this file. Okay, so this can be done by using which command? ln command. So ln command user include sys unistd.h followed by unireference. Okay, so here I am giving the path name unireference for this entire path, for this file. So even though I am in this directory, if I want to access this particular file, instead of giving the complete path name, I can just make use of this unireference instead of this complete path name. So that is because we are creating the path name for this file by using the command ln. Nothing but we have created the hard link for the file. Okay. So now let us take up the example how actually it will be organized in the directory file for hard links and symbolic links. Okay, we will take up the example for hard link. So that's why I have mentioned case 1, hard link. Okay, so this is the command. I am trying to create a hard link for this file. Let me say this is the directory /user mit followed by the file name. So for this I am creating a hard link, that is user program and with the file xyz. Okay, so let us see how it works, how it will be visualized. If you remember, the directory file contains the inode number and the file name. Okay, so let us say that this is the table for the directory /user mit. Okay, so inode number and then file name. We have some inode number and let's concentrate on this file, that is abc. So ABC is a file with the inode number 201. Okay, it is a file with the inode number 201. So let us see the directory user program. So this is the table for directory user program. This is inode table for this directory. So for this user program, we have current directory, parent directory and everything, and we have some other files. Let's look into the file xyz. So xyz. So xyz, this is the record row. So xyz has the inode 201. So if you observe, for ABC also we have the same inode number and xyz also same inode number. So we can conclude that in case of hard links, when we create the link for the file, so it creates a file but with the same inode number. So there will be no new file, instead of that it will be referring to the same inode number. So this is in case of hard links. Now let us see what happens with respect to symbolic links. So this is an example for symbolic link. So here we are creating a symbolic link by using ln-s command for the file abc, which is under user mit directory, with the name xyz, which is under user program. Okay, so now let us see the directory content. Okay, so inode number and file name. So abc, so what is the inode number of abc? It is 201. Okay, so next here, what is the inode number of xyz? It is nothing but 450. Observe here, in case of hard link, even this xyz has the same inode number as that of abc in the hard link case. But in the case of symbolic link, a new inode will be created. A new inode will be created for this file. So that is the difference between hard link and symbolic link. Okay. So now let us see what is the difference between cp command and ln command. Okay. Difference between cp command and ln command. So we are already aware of that. Cp is a command that is used to copy the content of a file into another file, whereas ln is used to create links for a file. So in case of cp command, only the contents of the file will be copied to the new file. So it will create a duplicate copy of the file in case of cp command. But in case of ln command, so we are creating the link, right? So we are creating a new path name in order to reference the file. So that is the major difference between cp and ln. I will repeat once again. So cp is for copying. So here if we make use of the command cp, that is copy command, it will duplicate the file. That means the contents of the file will be copied to another file, new file. Okay. In case of ln command, That means we are creating the links, we are creating a new path name in order to reference a file. So, okay. Now let us see what are all the limitations of hard link. Actually, there are two limitations of hard link. Okay, first one, user cannot create hard link for directories unless he has the super user privilege. Okay, so user cannot create hard links for directories. So normal user cannot create hard links for directories. Only he should has the super user privilege. That means he should have the special access privilege. That is because if a user is allowed to create a hard link for the directory, it might result into a cyclic chain link. Okay, so it might result a problem like cyclic link for a file. It's something similar to your infinite loop concept. Okay, so if the user is trying to create a hard link for a directory, so this might cause a cyclic link problem. Okay, so that's why user is not allowed to create hard link for directories unless he has the super user special privilege. Okay, and second limitation is user cannot create hard link for a file that is in a different file system. Okay, so user cannot create hard link for a file that is in different file system. So what is the reason behind this? We already know that in case of hard link, inode remains same for both the files or both the path names. Okay, inode remains same, but in case of file system, inode number of a file should be unique, or it is unique on different file system. So that's why hard links cannot be created for file across different file system. Okay, so these two are the limitations of hard links. Now let us see what is the difference between hard links and symbolic links. So hard link and then symbolic link. In case of hard link, we have already seen in the example that it does not create new inode. So it does not create new inode. In case of symbolic link, a new inode will be created. So that is the first difference. And second difference is by using this hard link, we can increase the hard link count of a file. If you remember, we have discussed file attributes of a file in Unix operating system in the previous session, right? So what are all the different attributes? File name and then file size, hard link count, etc. Okay, so here this hard link, by using this hard link, we can increase the hard link count of a file. Hard link count of a file will be increased. In case of symbolic links, so it does not alters the hard link count. Okay, so next, third one. So we already got to know that hard links cannot be created for directories. So it cannot be created for directories. We already discussed this in the limitations part. So hard links cannot be created for directories. In case of symbolic links can be created for directories. Okay, and one more difference is hard links cannot be created for files across different file system. So it cannot be created for file across different file system. Where in case of symbolic links, the symbolic links can be created for files even across different file system. Okay, and then the last difference is the command. So here I will write the example. I will write up here. So this is the fifth difference. So ln command is used here, and in this case ln-s, ln command followed by the file name and then followed by the path name mit /new. Similarly, here user mit old and then /user program new. Okay. So this is the last difference. So these are all the differences between hard links and symbolic links. Total there are 5 differences. First one is hard links. In case of hard links, new inode is not created, where in case of symbolic links, new inode is created. And second difference is hard links will increase the hard link count of a file. So but whereas in case of symbolic links, nothing will happen. In case of hard links, it cannot be created for directories, where in case of symbolic links, it can be created for directories. Hard links cannot be created for file across different file systems. Symbolic links can be created for files even though at different file systems. And last one is ln command and then ln-s. So this is all about hard links and symbolic links. Now let's move on to the next concept, that is Unix file APIs. We have already discussed there are different types of files in Unix system. So they are regular files, and then directory files, FIFO files, device files, and then symbolic link files. These are the different types of files in Unix operating system. Now let us discuss the APIs that are used for these files in the Unix system. APIs are nothing but application programming interfaces. It is mainly used for the manipulation of these files in the Unix operating system. There are many files, there are many APIs such as open, create, read, write, state, fstat, unlink, link, umask, utime, etc. And we will discuss each of these APIs one by one. So first let us take up the open system call or open API. Open API or the open system call, it establishes a connection between a file and process. If you remember, I was telling you that whenever a command has to be executed in Unix operating system, so this will create a process which in turn will be in the execution. Okay. So this open system call, this API will establish a communication or connection between a file and a process. So particularly this file, it is used to open an existing file. So this can be used to open an existing file, or it will create and open if it is a new file. Okay, understand properly. Open system call, it is used to open an existing file. At the same time, if a new file is tried to open, so this open API will first create that file and then it will open that new file. So now let us see the prototype of this open system call. So as I said, there are some other access modes that are termed as access modifier flags. These are nothing but those access modifier flags, and these can be combined with those 3 access modes, that is read only, RD only, WR only, and then RDWR. Among those 3 access modes, these access modes or nothing but access modifier flags can be combined. So among these, the starting 4 access flags are used for regular files. Okay, and this is used for FIFO file. Okay, and last one is used for device file. So all these 4 are used for regular files, and this is used for FIFO file, and this option is used for device file. Okay, the first one, O_append, indicates that so the content has to be appended to the end of the file. So as the name itself says, the content has to be appended to the end of the file. Next is creat. This creat option enables the open system call to create a file if the file does not exist. So I told you in the very first point itself, open system call can be used to open an existing file, or it can be used to create a new file. So here if I mention this creat, so this option enables the open system call to create a new file if it does not exist. Okay. Next is execution L, EXCL. So this system call, this access modifier, this is used to generate an error if the file exists and still creat option is used in the open system call. I will repeat once again. So this option O_EXCL. So this option is used to generate error. So error in which case, if the file already exists and even though it exists, creat option is used. As I told you, creat option is used only if the file is does not exist, and then in order to create the file, this option is used. But in this case, the file is already present and we are making use of this creat. In that case, this option is used to generate error. Okay, next is trunc. So this trunc option, it is used to truncate the file size in bytes if it is larger than the constant value. Okay, if you remember, I had told you like open max, name max, right? So if it is beyond that value, then the file size has to be truncated. So this option is used for that purpose. And then non-block, and previously it is available with n delay. So this is used to stop or continue the read or write operation. This option is used to stop or continue the read or write operation. So as I told you, this is used in FIFO files. It is mainly useful when the complete pipe, FIFO is nothing but the complete pipe, right? The pipe is full or if the pipe is empty. That means if the write operation is performed on a pipe that is full, or if a read operation is performed with a pipe that is empty, in such case this option is used, that is non-block. That means it will stop the read operation if the pipe is empty, and it will stop the write operation whenever the pipe becomes full. Okay. And next one is no CTTY, that means no control terminal. So this is for device file. So this is used to disable the terminal device file for the calling process terminal, because the calling process terminal will be already in the active state. So the terminal's device, okay, the terminal device, that has to be disabled. Since the already calling process terminal is enabled, so the device's terminal has to be disabled. For that purpose, this no CTTY, that means no control terminal option is used. As I told you, along with those three, that is O_RD only, O_WR only, O_RD WR, these access modifier flags are used in order to open a file. Now let us see the example. How I will just write one example, okay, how I can create a file by using this, how I will open a file by using this open system call. See this example here. I am invoking this open system call. I am passing three arguments. The first argument is the path name. So I am trying to open the file USP that is present under user/MIT directory. Okay. And second argument is access mode. So access mode, I told you already, there are three access mode. So they are read only, write only, or read write. Along with that, some more access modifier flags can be combined by using bitwise OR. So here what I am doing here, I am saying RDWR, I am using bitwise OR operator followed by the access modifier flag O_append. Okay. And then the third argument, permission, is given as 0. So anyways, permission, the third argument, is used only when a new file is created. Okay. The third argument is used only when a new file is created. Here I am just trying to open the file, existing file, so that's why I am not mentioning the third argument. Simply I have given it as 0. Anyways, I will discuss about this now after this. Okay. So as of now, look into this. Okay. Open system call will return a file descriptor or anything. It returns an integer, right? So that's why on left hand side I have taken it as int fd. Okay, so int fd. So if it is successful, it returns the file descriptor. If it is if there is any failure, then -1 will be returned. Okay, so this is one example how we can open an existing file. Now let us look into the third argument, that is permission. As I told you, this third argument, this permission is used only when a new file is created. So let us see what are all the permissions that can be given for a file. Actually here the permission is a term that is used to give the permission, to give the accessibility for different types of users in Unix system. There are different types of users, that means the user, group and then others. User is nothing but the owner and then group and for others. So different permissions like read, write, execute can be given to these three different users, that means the owner, group as well as the others. Okay, we have one table for that. So these are the symbols that can be mentioned as third argument for this open system call. Okay, so what are these symbols? What does it indicate? Actually I told you, right, there are three types of people in the Unix system, that is owner, group and then others. So there are three types of users, that is owner, group and then others. Okay, so for owner we shall mention it as user, okay, U, and then group G and then others O. Okay, so for each of these set of users, read, write, execute access or permission can be assigned. If you remember, by using the commands we were giving the permission by using an octal integer representation. Okay, octal integer representation in which read operation was 4, write was 2 and then execute was 1. Okay, and the users will be UGO. Suppose, so in octal representation, if I am saying that 444, then so 4 is for read operation, right? So the owner has got read permission, the group has got read only permission and others have got read permission. If I mention 6 here, so it indicates that user, that means the owner will have the read and write permission and group will have the read permission and others will have the read permission. If I have to give the complete permission, then I should mention like this 777. It indicates that the user, I mean the owner, group and others, all the three types of users will have read, write and then execute permissions. So this is the octal integer representation of the permission given to access a file by different users, that is the owner, group and others. The same thing is represented by these symbols here for the open system call. So that's why the return type is mod_t. The first option or the first symbol specifies that read operation for user. So that means for owner, read, that is for the owner, and then write only for owner, execute only for owner, read, write, execute for owner. Okay, and next read for the group, write for the group, execute for the group, read, write, execute for the group. Similarly, read for others, write for others, execute only for others, read, write, execute for others. So by using these one of the symbols, we can give the permission for different type of users in order to open the file, or in order, actually this option is used whenever a new file is created. Okay, so whenever a new file is created, this option can be used. So this is all about the open system call. Now let's look into the next system call or next API, that is create. So create API, observe here, for this I have used the spelling CREAT, okay, it's not ending with E. So CREAT, that's all. So this is the API or this is the built-in system call. So this system call is used to create a new file in the Unix operating system. It is used to create a new file, okay. So next, this is the prototype of the create system call. So it is defined under sysbar types.h and then unistd.h. So here we have the create, the name of the system call, and the return type is int, so it's an integer, and it takes two arguments. One is path name and another one is mode, okay. So here int, the return type is int, so the return value will be the file descriptor if the file is created successfully, otherwise -1. So the return value will be the file descriptor or -1. File descriptor if the file is created successfully and -1 if there is any error, okay. And the first argument is the path name. The path name, as I told you in the previous example itself, it gives the path name of the file which has to be created. So either it can be absolute path name or relative path name, whatever. So anyways, the new file which has to be created, that will be given as the first argument in the create system call. And the second one is mode. So mode, I already told you the different symbols that are used to give the permissions or different modes of access to the file. So the same concept is applied here. So for create system call, we have different permissions: read, write, or read only, or write only, or execute, or all the three: read, write, execute permission for different types of users, that is for owner, group and others. We already seen in the previous system call, that is s_ir OTH, like that. So same values or same symbols are used here as a second argument. I already told you that the open system call can also be used to implement the create system call. If the file does not exist, the open system call, it creates that file and then opens that file. So that means the create system call can be implemented by using open system call. Let us see how this will be implemented. So this is how we can implement the open system call to in order to create a file, okay. So for create path name followed by the mode, this can be replaced by using open system call with the path name, and then since we are creating, the option is taken as write only, and along with that create option, I told you already, _create option is used whenever a new file has to be created, okay. And then trunc option in order to truncate, and then the mode, the last one, remains as it is. So this is how we can implement the create system call using the open system call, okay. So in today's class, we have discussed about the hard links and symbolic links and the difference between those two, the limitations of hard links, and then we took up the concept of Unix file APIs. So Unix file APIs are nothing but the built-in system calls that are used for different types of files such as regular files, device files, directory files, and then symbolic link files and FIFO files. So out of which the first one was the open system call. Open system call, it is used to create, it is used to open an existing file, or it will create and open if the file is new file, okay. So we discussed about the prototype, and then we discussed about the return type. Actually open system call returns the file descriptor if it is successful, otherwise -1. And then we discussed each of the arguments, that is the path name and then the access mode and the permission. So next is the create system call. This system call, it is used to create a new file in the Unix operating system. So the prototype is like this. It takes two arguments, one is path name and another one is mode, okay. So path name, again either it can the file name, so it can be absolute path name or relative path name, okay. So the return type or the return value is nothing but the file descriptor if the file is created successfully, otherwise -1. and then the create system call can be implemented by using open system call, and this is the representation how the create system call will be implemented by using open system call. Okay, so thank you.